There is a $2 bottle of liquid on the shelf at your pool store that can take water so cloudy you can't see your own hand and turn it glass clear in a matter of hours. It isn't chlorine. It doesn't kill anything. And almost nobody who pours it in knows they're using one of the oldest tricks in the history of clean water, a piece of chemistry a city put to work on a muddy river more than 100 years ago. And then almost everyone forgot. So here's the question worth sitting with. If one cheap liquid can clear the dirtiest water this fast, this cheaply, what is it actually doing in there? Because the honest answer is stranger and more useful than the label on the bottle. And there's a catch inside it. The same trick that makes your water look perfect can quietly fool you into thinking it's clean. That's the whole point of this video. Stay with me. Start with the problem this was invented to solve. Cloudy water is not usually dirt you can filter out. The stuff hanging in it is far too fine, colloids, particles so tiny they never settle and never strain out, silt, fine clay, broken down organic matter, the ghost of last week's algae. And here's why they refuse to settle, which is the key to this whole story. Each particle carries a faint negative charge, and like the wrong ends of two magnets, like charges push apart. So every particle in that cloud is constantly shoving every other one away. They can't clump, they can't fall, they just hang there scattering light. A filter alone will chase that haze forever. Now, the story of how we beat it starts on a muddy American river in the 1890s. The Ohio River at Louisville, Kentucky, ran brown, and for decades the city's engineers had struggled to give people clean water out of it because slow, gentle filters simply choked on that much mud. In 1895, the Louisville Water Company brought in a young sanitary engineer named George Warren Fuller, 26, trained at MIT and in Berlin, and handed him one of the hardest water problems in the country. From 1895 to 1897, Fuller ran experiments that quietly rewrote how the world cleans its water. His insight: don't fight the mud at the filter, deal with it before the water ever reaches the sand. So he added a chemical to the muddy water first: alum aluminum sulfate, a compound cheap and common enough that it had been used in one form or another since antiquity. And the cloudy water changed in front of him. The fine particles that had refused to settle for decades suddenly gathered into visible clumps and sank. That was the breakthrough. Treat the water chemically first, and you can then push it through sand far faster than anyone thought possible. His work became the foundation of rapid sand filtration, and in 1902 the first full-scale modern plant built on his findings opened at Little Falls, New Jersey. Within a generation, it was how a serious city cleaned its water. Fuller ended up nicknamed the father of sanitary engineering. One honest note here, because it connects to something you may already know. If you've heard we once cleaned whole cities' water with nothing but slow sand and a living layer, that's true. And it's the opposite method, no chemical at all, leaning on biology and time. Fuller's method added a chemical precisely so the filter could run fast and small. Coagulation was invented to make the fast filter possible. The two aren't rivals. They are two answers to the same muddy river, and the fast chemical one is the one that ended up humming next to your pool. But notice what Fuller was working with. Powder alum dosed into the water. It worked, but it was fussy, slow to mix, and it lost its grip in cold water. The next leap wasn't a new powder, it was a liquid, and it came out of Chicago. In the 1930s, an engineer named John Baylis working on Chicago's water, was chasing a way to make coagulation stronger and more reliable, especially in cold water. What he developed sounds like alchemy, but it's real chemistry. He started with sodium silicate, a syrupy, glassy liquid that goes by an old name, water glass or liquid glass. It's literally glass in a bottle, silica dissolved into liquid form. He partially neutralized it with a measured dose of acid. Not enough to make it fall apart, just enough to wake it up. The result was something new. A faint, invisible sol of microscopic silica particles, activated and hungry to grab on. He called it activated silica, and in 1940 he was granted a United States patent for it, patent 2,217,466, the first true flocculant, the first liquid additive designed specifically to build bigger, tougher clumps out of water's finest junk. And around the same years, the hardware caught up. In Springfield, Illinois, the city's first water plant superintendent, Charles Spaulding, patented a tank that did the whole job in one graceful motion. Water pushed slowly upward through a suspended blanket of settling sludge, the clumps forming and dropping as it rose, clear water spilling off the top. His precipitator went into service on Springfield's water in 1935. Liquid chemistry and a machine built around it arriving together. So hold the whole picture. A muddy river in the 1890s, a powder that made the mud clump, a liquid made from glass in the 1930s that made it clump better. That's the ancestry of the bottle on your pool shelf. Now let's open it, because how it works is the part the label never explains. Remember why the haze won't clear. Every tiny particle wears the same negative charge, and like charges repel, so nothing can clump and nothing can sink. Coagulation attacks that directly. Add a coagulant like alum, and it releases positively charged aluminum into the water. Those positive charges swarm the negatively charged particles and cancel out the electrical shove that held everything apart. Engineers call that surface charge the zeta potential. Knock it towards zero and the particles stop repelling each other. It happens in a second or two, and the instant the repulsion is gone, the particles start bumping into each other and sticking. That's coagulation. The charge is killed and the particles begin to gather. Then comes the second step, flocculation. And this is where the liquid glass earns its keep. A flocculant like activated silica acts like a molecular net. Its long, fine strands reach from one particle to the next and bridge them, lacing small clumps into visible, settleable flakes the trade calls flock. Coagulation neutralizes, flocculation bridges. One kills the charge, the other ties the pieces into something you can remove. Picture a room full of magnets all pointed to repel each other, drifting apart, never touching. Coagulation flips half of them so they suddenly attract. Flocculation runs a thread through the whole cluster and pulls it into one heavy knot that drops to the floor. That knot is the flock. That's what makes your water clear. Either way, bridging, or at higher doses a sweeping mesh of aluminum hydroxide that drags particles down as it settles, the end game is the same. Turn an unsettleable haze into clumps heavy enough to lose to gravity. Now bring it home to your backyard, because this is where the $2 bottle splits into two products people constantly mix up. One is a clarifier, usually a mild, positively charged polymer that works gently, coaxing the particles into clumps just big enough for your normal filter to catch over the next few passes. It's slow, a day to 3 days, works with almost any filter, and it's staggeringly cheap. A single quart can treat well over 100,000 gallons, so a backyard dose is a few cents worth. That's the honest version of the $2 claim, not free but close. The other is a flocculant, often straight aluminum based, the heavy artillery. Instead of small clumps for the filter, it drops everything into large, dense flock that sinks to the floor in hours. But that pile is now full of the junk you removed, and running it through your filter just blows it back into the water. So you don't filter it, you vacuum it up manually, straight to waste. Faster and more dramatic than a clarifier, but more work. It needs the right kind of filter, and it dumps some water. Same chemistry Fuller and Baylis worked out a century ago, tuned 2 ways for 2 jobs. So the science is real, 100 years proven, on the shelf for pocket change. Which is exactly the moment an honest video has to slow down, because this is where the trouble hides. Here's the catch, and it's the most important thing in this video, so give me the next 90 seconds. Making water clear and making water safe are 2 completely different jobs, and this liquid only does the first one. A clarifier or a flocculant removes particles, that's all. It does not kill a single germ. It does nothing to disinfect the water, and nothing to stop it being recontaminated the moment the next person gets in. The makers say exactly that. Clarifying is a cosmetic mechanical fix. It is not sanitation and was never meant to be. The disinfection, actually killing the bacteria and viruses that make swimmers sick, is chlorine's job, and only chlorine's or another registered sanitizer doing the same work. The US Centers for Disease Control puts numbers on it. Free chlorine, at least 1 part per million in a pool, at least 3 in a hot tub, pH held between about 7.2 and 7.8, so the chlorine can work. That's the line between safe and not. A clarifier isn't on it because it doesn't belong there. And now the genuinely dangerous part, the reason this matters more than any other water trick. Cloudy water isn't just ugly, it can physically shield germs from chlorine, giving them somewhere to hide from the very thing trying to kill them. That's why health guidance treats a hazy pool as a real hazard, not a cosmetic one, and why you're told never to let people swim in water you can't see the bottom of. So think about what happens when you reach for the clarifier the wrong way. Pour it in, the water goes beautifully clear, but your chlorine has crashed, and you've built the single most deceptive situation in pool safety. Water that looks perfect, water that is not disinfected at all. Clear is doing all the talking and clean has left the room. The haze that would have warned you is gone, and nothing has been made safe. One common mistake makes it a trap. If you've got living algae, you're supposed to kill it first with chlorine, and only then clear the dead remains. Skip that, clarify first, and you get gorgeous water with a live problem still in it. And a few plain limits. These products only work in the right pH window. Overdosing clouds the water and drags pH down, and a flocculant clogs a cartridge filter fast, which is exactly why it's meant to be vacuumed to waste, not filtered. So here's the whole thing tied off. That $2 liquid is real and genuinely clever. The direct descendant of a muddy river breakthrough from the 1890s, and a patent for liquid glass from 1940. A century of chemistry refined into a bottle that can rescue the cloudiest water you've ever seen. Used right, on the right problem, it's one of the best value things in the whole pool aisle. The chemistry works. The history is real. None of that is the trick. The trick is what your eyes do with the result. Coagulation was only ever designed to answer one question: is the water clear? And it answers it beautifully. It has nothing to say about the question that actually matters: whether the water is safe. A muddy river taught us to pull the haze out of water more than a century ago. It never taught us to make water clean. Those were always 2 different jobs. And the water that looks the most perfect is the one most able to lie to you. Clear, not clean. Learn the difference, or the water will teach it to you.